Hello students, how are you? Today we will speak about heat and phase change and the states of matter and plasma. Okay, so let's begin. So please have with you a pen to take note, and just to remember you that this class is an extension of the page or the class or the lesson that you have in the book. So you need to combine to resolve the answers. Okay, so this is just as I told you, an extension. Okay, so you need to read the text to answer the question of the worksheet. Okay, so let's begin. So there is three states of matter. There is the solid, the liquid, and the gas. So changes are due to a loss or gain of heat. Okay, so solids to liquid is equal melting. This is the how to pass from solids to liquid. This point is called the melting point. From liquid to solid is equal freezing. So this point is called the freezing point. Like for example, we have water. When it will be to ice, it will be the state of freezing. So freezing point is affected by solutes. Latent heat. So solid to liquid produces temperature change. This is called latent heat. Heat of fusion. Heat required to turn a certain amount of solid into liquid without changing temperature. Okay, so now the evaporation and condensation. So it's evaporation of a liquid to a gas. Factors that affect the evaporation are in general higher temperature, greater surface area, and airspeed over a liquid. For example, evaporation, like the sun, with the evaporation, for example, of the sea water. So when it's evaporate, we will have something called the rain. Okay, and now the evaporation. Liquids that evaporate quickly are volatile. Liquids that evaporate slowly are involatile. So there is two states. These liquids that evaporate directly are volatile, and that they do not evaporate directly are involatile. So now, internal evaporation. Evaporation that takes place in the liquid as opposed to the usual surface. Requires high heat. This is also called boiling, when evaporation is throughout the liquid. Boiling. Okay, so boiling, an example of boiling, for example, when you put on the heater the water to make, for example, coffee. When the water begin to boil and you see this, how to say, this steam going out, this is the evaporation. Okay, boiling. Evaporation will not occur any quicker above 100 degrees. Okay, so in general, the evaporation of the water, the temperature of evaporation of water is 100 degrees in general. Now pressure. It affects the boiling point. Control the pressure and control the boiling point. Okay, this is about the pressure. Pressure cooker now uses pressure to make food cook faster. Okay, this is an example of the kitchen when you use the cooker. Okay, to cook more fast. Okay, the food, for example, the beans or something like that. You put it on the how to say, when it cooks very higher, in higher point. Okay, higher temperature. Heat of evaporations. Heats are required to change a given amount of liquid into a gas without raising the temperature. Okay, and condensation. Now the condensation is the state of gas changing into a liquid. This happens when warm things get cold. The saturation point. It is when an amount of a water evaporating equals the amount of condensing. And evaporation and condensation. Heat flows from higher to lower concentration. Then refrigeration is using heat and condensation. Principle of refrigeration. When a gas is compressed, its temperature rises. When a gas is allowed to expand, its temperature falls. When a liquid evaporates, it absorbs heat from the surroundings. When a gas condenses, it releases heat into its surroundings. And now the sublimation. A gas changing directly into solid. So this is the states, the process, for example, this sublimation when the gas is changing into solid. Here when we speak, for example, when we speak about condensation, it's when the gas change into liquid. So just for you to not get confused. And the four states of matter is called plasma, superheated gas. So we will see it here. The plasma is the fourth state of matter. Plasma is an ionized gas, that means that have ions. A gas into which sufficient energy is provided to free electrons from atoms, electrons that are negative charges, okay, from atoms or molecules, and to allow both species, ions and electrons, to coexist. Okay, ions, for example, it's something can be positive, negative, it's in chemistry, okay, and electrons, something, for example, that have a negative charge. Ions can be electrons or another thing that are protons, for example, that can be positive. In effect, a plasma is cloud of protons, neutrons and electrons, where all the electrons have come loose from their respective molecules and atoms, giving the plasma the ability to act as a wall rather than a lunch of atoms. So plasma is a combination or is a cloud of protons, neutrons and electrons. Protons are positive, neutrons that have no charge, and electrons are the negative charge. Okay. So some examples of plasma are lighting sun and, let's say, nebula, or this aurora borealis. Okay. So this is the class for today. I hope you have enjoyed. If you have any question, please let me know. Okay. Thank you.